On the morning of March 14, 2019, a commercial airliner operating as Transcontinental Flight 891 landed at its destination with fuel reserves that should not have existed. The Boeing 737-800, carrying 163 passengers and 6 crew members, touched down at Dallas-Fort Worth International Airport with approximately 2,400 pounds more fuel than its flight management system indicated it should have consumed. The discrepancy was noted during standard post-flight checks. What made this notable was not the fuel itself, but what the data suggested about the flight's duration, altitude profile, and the segment of airspace the aircraft had occupied between 10:47 and 10:51 a.m. Central Standard Time. The investigation that followed would reveal a pattern of inconsistencies that defied conventional explanation. Data from multiple independent systems, each designed to provide redundant verification of the aircraft's position and status, told conflicting stories about those 4 minutes. And as investigators dug deeper, they discovered that Flight 891 was not an isolated case. It was simply the most thoroughly documented. The flight had departed Phoenix Sky Harbor International Airport at 9:32 a.m. local time, 13 minutes ahead of schedule. Weather conditions were optimal across the entire route. Visibility exceeded 10 miles at both departure and destination airports. Winds aloft were light and predictable, with forecast headwinds of only 15 to 20 knots at cruise altitude. The routing was standard for this city pair. Victor 16 northeast to the Albuquerque VOR, then direct to the Pecos intersection before joining the Star arrival into Dallas. Total planned flight time was 2 hours and 18 minutes. The aircraft, registered November 738 Charlie Tango, had entered service in 2011 and carried no outstanding maintenance deferrals. Both engines were operating within normal parameters. The captain had logged over 12,000 hours, with 4,000 hours in type. The first officer had 6,200 hours total time, with 1,800 in the 737. The pre-flight preparation had been routine. The captain conducted the walk-around inspection, while the first officer programmed the flight management system. Fuel load was verified at 23,800 pounds. This figure was confirmed by 2 separate fuel trucks, both equipped with calibrated flow meters. The fueling supervisor signed off on the load at 9:14 a.m. The captain reviewed the fuel slip and compared it to the flight plan's required fuel. 18,200 pounds for the flight, plus a 45-minute reserve, plus alternate fuel for the designated alternate airport in San Antonio, plus additional contingency fuel per company policy. The loaded fuel exceeded the requirement by 1,000 pounds, providing an additional buffer. Everything was by the book. Flight 891 pushed back from gate B-17 at 9:28 a.m. The pushback and engine start were normal. The aircraft taxied to runway 25 right and was cleared for takeoff at 9:32 a.m. The takeoff roll, rotation, and initial climb were unremarkable. Phoenix Departure Control cleared the flight to climb to flight level 230 and proceed on course. The captain engaged the autopilot at 400 feet above ground level. The aircraft climbed smoothly through the morning air. At 9:47 a.m., Phoenix Departure handed the flight off to Albuquerque Center. The first officer checked in on the new frequency, reporting level at flight level 230. The Albuquerque controller acknowledged and cleared the flight to climb to flight level 370. The captain selected the new altitude in the mode control panel. The aircraft began its climb at the standard rate of approximately 2,000 feet per minute. At 10:12 a.m., the flight leveled at 37,000 feet. Fuel remaining at that point was 20,100 pounds. The flight management system calculated fuel at destination would be 5,300 pounds, well above the minimum required reserve. Flight 891 climbed to its assigned cruise altitude of 37,000 feet without incident. Air traffic control handed the flight off from Albuquerque Center to Fort Worth Center at 10:39 a.m. The handoff was routine. The controller in Albuquerque transmitted, "Transcontinental 891, contact Fort Worth Center on 124.75. The first officer read back the frequency and switched. He checked in with Fort Worth at 10:40 a.m. stating, "Fort Worth Center, Transcontinental 891 is with you, level 370. The controller acknowledged with a simple, "Transcontinental 891, Fort Worth Center, radar contact." No further instructions were issued. The flight was proceeding on course, on speed, on altitude. The autopilot was engaged. The weather radar showed clear skies for the next 200 nautical miles. The aircraft was in smooth air. Both pilots were relaxed, engaged in the routine monitoring tasks that comprised the majority of cruise flight. The Fort Worth Center controller on duty that morning was a 14-year veteran named Michael Reeves. He had worked the high-altitude sector covering central Texas and eastern New Mexico for the past 6 years. His sector was moderately busy that morning, with 12 aircraft under his control. Flight 891 was the third aircraft from the left on his radar display, proceeding eastbound at flight level 370. The data block next to the radar return showed the aircraft's call sign, altitude, and ground speed, 476 knots. At 10:47 a.m. and 16 seconds, Controller Reeves glanced at his scope during a routine scan. The Mode C transponder return from Flight 891 displayed an altitude of 37,000 feet, exactly as expected. He looked away to coordinate with an adjacent sector about an aircraft requesting a higher altitude. 4 seconds later, at 10:47 and 20 seconds, he looked back at his scope. The return from Flight 891 now displayed an altitude of 41,000 feet. The radar system updated every 4.7 seconds. There was no intermediate altitude captured between the two sweeps. No climb rate was observed. The aircraft's data block simply reflected the new altitude on the subsequent sweep, as if the aircraft had jumped instantaneously from 37,000 feet to 41,000 feet. Controller Reeves stared at the display for a moment. In 14 years of air traffic control, he had seen transponder errors before. Altitude reporting could be affected by electrical faults, interference, or encoding problems. But those errors typically manifested as obviously incorrect altitudes, often outside the aircraft's performance envelope, or as wildly fluctuating numbers that jumped erratically. This was different. 41,000 feet was a valid altitude, within the aircraft's certified ceiling, and only 4,000 feet above the assigned altitude. It was plausible enough to be real, but the instantaneous change was not. He keyed his microphone. Transcontinental 891, Fort Worth Center, confirm your altitude. He kept his voice neutral, professional. There was no response. He waited 5 seconds, then repeated the call. Transcontinental 891, Fort Worth Center, say altitude. Still no response. The data block continued to display 41,000 feet. The aircraft's ground speed, which had been 476 knots, now read 471 knots. That was consistent with a higher altitude, where the thinner air would result in a slightly lower true airspeed for the same indicated airspeed. Controller Reeves flagged the discrepancy on his display and verbally alerted his supervisor, who was standing behind him monitoring the sector. At 10:48 a.m., Controller Reeves attempted contact a third time. Transcontinental 891, Fort Worth, radio check. This time, the first officer responded. His voice was calm and clear, but there was a brief pause before he spoke, as if he had been momentarily distracted or had needed a second to process the call. Fort Worth, Transcontinental 891, loud and clear. The controller immediately followed up. Transcontinental 891, confirm your altitude. Another brief pause. Fort Worth, we're level at 370. Controller Reeves looked at his scope. The data block still showed 410. He keyed the microphone again. Transcontinental 891, I'm showing you at flight level 410 on my scope. Confirm you're indicating 370 in the cockpit. This time the pause was longer, perhaps 3 seconds. Affirmative, Fort Worth. Both altimeters indicate 370, primary and standby. No alerts, no warnings. Everything looks normal up here. The supervisor, now leaning over Controller Reeves's shoulder, studied the display. He had already checked for other aircraft in the vicinity. There were none within 20 nautical miles. There was no possibility of a confused target or overlapping transponder codes. He instructed Reeves to have the flight recycle its transponder. Controller Reeves transmitted the instruction. Transcontinental 891, recycle your transponder, please. The first officer acknowledged. Recycling transponder, Transcontinental 891. On the scope, the data block for Flight 891 flickered and disappeared for approximately 2 seconds. When it reappeared, it displayed 37,000 feet. The ground speed returned to 476 knots. Controller Reeves and his supervisor exchanged a glance. "Looks like a transponder glitch," the supervisor said. Controller Reeves made a note in his log. "TCA 891, mode C discrepancy, 1047Z, recycled XPDR, resolved." He transmitted to the flight. "Transcontinental 891, I have you back at 370, appears normal now." The first officer replied, "Copy that, Fort Worth, Transcontinental 891. The flight continued without further comment. At 10:51 a.m., the aircraft crossed into the next controller's airspace and was handed off. Controller Reeves passed the flight to the next sector with a standard handoff. He mentioned the transponder issue verbally during the handoff. The receiving controller acknowledged but reported no further problems with the flight. The remainder of Flight 891's journey proceeded normally. The aircraft began its descent at 11:24 a.m. and landed on runway 18 right at Dallas-Fort Worth at 11:57 a.m., 6 minutes ahead of schedule. The passengers deplaned. The crew completed their post-flight duties. The aircraft was refueled and prepared for its next flight. Everything seemed routine. But when the maintenance technician reviewed the post-flight data as part of standard procedure, he noticed something unusual in the fuel log. The arrival fuel quantity was higher than expected, significantly higher. The technician pulled up the fuel summary. Departure fuel, 23,800 pounds. Arrival fuel, 7,700 pounds. Fuel consumed, 16,100 pounds. He cross-referenced this with the flight plan. The planned fuel consumption for a flight of 2 hours and 18 minutes at the aircraft's weight and cruise altitude should have been approximately 18,500 pounds. The actual consumption was 2,400 pounds less. He checked the flight time. Block out at Phoenix, 9:28 a.m. Block in at Dallas, 11:57 a.m. Total block time, 2 hours and 29 minutes. Actual air time, wheels off to wheels on, 2 hours and 25 minutes. The flight had taken 7 minutes longer than planned, yet had consumed significantly less fuel. That made no sense. Longer flight time should mean more fuel consumption, not less. The technician ran the numbers again. For a 737-800 at that weight and altitude, fuel burn is approximately 5,000 pounds per hour or 83 pounds per minute. For a 2 hour and 25-minute flight, total consumption should have been approximately 18,400 pounds. The actual consumption was 16,100 pounds. The difference was 2,300 pounds, or approximately 28 minutes of flight time at normal cruise consumption. The technician documented the discrepancy and forwarded it to the maintenance supervisor. The supervisor reviewed the data and cross-checked it with the engine monitoring system. The FADEC, or Full Authority Digital Engine Control System, recorded every parameter of engine performance in real time. Fuel flow, exhaust gas temperature, N1 and N2 turbine speeds, throttle position, all were logged continuously throughout the flight. The supervisor pulled the FADEC data for Flight 891. The data showed no anomalies. Fuel consumption matched the calculated burn for the recorded altitude, speed, and atmospheric conditions. Both engines had operated normally throughout the flight. The fuel flow meters had functioned correctly. The total fuel consumed, according to the FADEC, was 16,100 pounds. The engines had performed exactly as expected for the flight profile they had flown. There was no indication of sensor error or recording malfunction. But here was the problem. If the engines had consumed 16,100 pounds of fuel, and if the fuel burn rate was normal for the altitude and conditions, then the flight time should have been approximately 1 hour and 55 minutes, not 2 hours and 25 minutes. Either the aircraft had flown for 30 minutes at some impossibly low fuel consumption rate, or the recorded flight time was incorrect. The maintenance supervisor contacted the airline's flight operations department. He explained the fuel discrepancy and requested a review of the flight's logged data. The operations analyst pulled up Flight 891's complete record. The flight management system, which calculates time, distance, and fuel remaining based on GPS position and aircraft performance, was retrieved and analyzed. The FMS showed the aircraft had followed its flight plan precisely. Every waypoint was crossed at the correct time relative to departure. Every altitude change occurred when expected. The FMS logged a total flight time of 2 hours and 25 minutes from takeoff to landing. The analyst then checked the GPS track log. Modern aircraft continuously record their GPS position, creating a breadcrumb trail of the flight's path. The GPS data for Flight 891 showed an unbroken track from Phoenix to Dallas. Every position report was time-stamped. The analyst calculated the ground speed at various points along the route and compared it to the FMS data. They matched. The aircraft had flown the distance it was supposed to fly, at the speed it was supposed to fly, taking the time that distance and speed would require. But when that time was correlated with the fuel burn, the numbers did not align. The analyst created a spreadsheet. On one axis, time. On the other, fuel. The two variables did not intersect correctly. If time was correct, fuel consumption was too low. If fuel consumption was correct, time was too long. There was a gap of approximately 30 minutes that could not be reconciled. The analyst sent a report to the Director of Flight Operations, flagging the discrepancy as unusual and recommending further investigation. The director reviewed the report and made the decision to notify the FAA. Under federal aviation regulations, operators are required to report certain types of anomalies, particularly those involving aircraft systems that could indicate a safety concern. While a fuel discrepancy alone might not rise to that level, the combination of the fuel issue and the radar altitude anomaly that had been noted by Fort Worth Center was sufficient to warrant a report. On March 18, 2019, 4 days after the flight, the airline submitted a service difficulty report to the FAA. The report detailed the altitude discrepancy observed by Fort Worth Center and the fuel variance observed post-flight. It included copies of the flight plan, fuel logs, FADEC data, FMS logs, and GPS track. The report concluded by stating that maintenance had found no faults with any aircraft systems and that the cause of the discrepancies was undetermined. The FAA opened an inquiry. The case was assigned to an aviation safety inspector based in the Dallas Flight Standards District Office. The inspector, a former airline pilot with 23 years of experience, began by reviewing the submitted documentation. He noted immediately that the two anomalies, altitude and fuel, had occurred during overlapping time periods. The altitude discrepancy was observed at 10:47 a.m. The fuel discrepancy suggested a gap in fuel consumption that would have had to occur during cruise, which was the period between 10:12 a.m. and 11:24 a.m. The 4-minute window from 10:47 to 10:51 a.m. fell within both anomalies. The inspector requested additional documentation. He asked for the raw radar data from Fort Worth Center, the voice recordings from the frequency Flight 891 had been operating on, and the complete avionics logs from the aircraft, including the flight data recorder summary if available. He also requested interviews with the flight crew and with Controller Reeves. The radar data was delivered in its raw digital format 3 days later. It included every transponder return from Flight 891 during its time in Fort Worth Center's airspace, with precise timestamps for each sweep. The inspector loaded the data into analysis software. The visualization confirmed what Controller Reeves had observed. At 10:47:16, the Mode C altitude was 370, or 37,000 feet. At 10:47:20, it was 410, or 41,000 feet. At 10:47:25, it was 410. At 10:47:29, it was 410. At 10:47:34, it was 410. At 10:47:38, it was 410. At 10:47:43, it was 410. Then at 10:47:47, it returned to 370. The inspector studied the pattern. The altitude had jumped to 41,000 feet and remained there for approximately 27 seconds across 6 radar sweeps before returning to 37,000 feet. This was not a single erroneous return. It was a sustained indication. If it was a transponder error, it was a very specific one. A consistent 4,000-foot offset that lasted for half a minute, then corrected itself. The inspector then examined the position data. Each transponder return included not only altitude, but also the aircraft's position in space, calculated by triangulation from multiple radar sites. He plotted Flight 891's position during the anomalous period. The aircraft's lateral position remained on course. There was no deviation from the flight path. The ground speed, as calculated from the change in position over time, was consistent with the aircraft's normal cruise speed, with a slight decrease during the 27-second period that the altitude showed 410. That decrease matched what would be expected from the increased altitude, where thinner air results in lower true airspeed for the same power setting. In other words, the radar data suggested that the aircraft had, for 27 seconds, actually been at 41,000 feet, not 37,000 feet. The position, speed, and altitude were all internally consistent. The data looked real, but the cockpit instruments, the FADEC, the FMS, the GPS altitude, and the crew's direct observation all indicated the aircraft had remained at 37,000 feet. Those data sources were also internally consistent. They also looked real. The inspector requested the voice recordings. The FAA maintains archives of all air traffic control communications. The recordings from Fort Worth Center for the morning of March 14th were retrieved and provided. The inspector listened to the relevant segment multiple times. He noted the timestamps on the recordings and compared them to the radar data. They matched precisely. At 10:47:52, Controller Reeves's first call, Transcontinental 891, Fort Worth Center, confirm your altitude. Silence. At 10:48:01, the second call, Transcontinental 891, Fort Worth Center, say altitude. Silence. At 10:48:11, the third call, Transcontinental 891, Fort Worth radio check. At 10:48:14, the first officer's response, Fort Worth Transcontinental 891, loud and clear. The inspector noted the 3-second delay. At 10:48:17, the controller's follow-up, Transcontinental 891, confirm your altitude. At 10:48:20, the first officer, Fort Worth, we're level at 370. The inspector listened to the first officer's voice. It was calm, clear, and professional. There was no indication of stress, confusion, or alarm. The tone was routine, but there was that pause. 3 seconds is not long, but in aviation communications, where responses are typically immediate, it was noticeable. The inspector played it again. The pause felt deliberate, as if the first officer had needed a moment to collect his thoughts or to verify something before responding. At 10:48:25, Controller Reeves, Transcontinental 891, I'm showing you at flight level 410 on my scope. Confirm you're indicating 370 in the cockpit. At 10:48:31, the first officer, affirmative, Fort Worth. Both altimeters indicate 370, primary and standby. No alerts, no warnings, everything looks normal up here. Another pause, this one longer. 6 seconds. The inspector noted it. The inspector contacted the airline and requested interviews with the captain and first officer of Flight 891. The airline coordinated the meetings. Both pilots were still actively flying and agreed to cooperate with the investigation. The interviews were conducted separately in a conference room at the airline's operations center in Phoenix. The captain, whose name was Robert Chen, was 54 years old. He had been flying for the airline for 19 years. He was calm and articulate during the interview. The inspector asked him to describe the flight in detail. Captain Chen recalled it as entirely routine. Weather was good, aircraft was performing normally, no mechanical issues, no unusual traffic. He remembered the controller asking about their altitude, but had assumed it was a radar or transponder issue. Those things happened occasionally. He had seen the first officer check the instruments and confirm their altitude, and that had been the end of it as far as he was concerned. The inspector asked if he had noticed anything unusual about the flight at any point. Captain Chen thought for a moment, then said no. He was then asked specifically about the time period between 10:45 and 10:55 a.m. Did he notice anything during that window? Any changes in the aircraft's handling? Any unusual sounds? Any changes in cabin environment? Any sensations or perceptions that stood out? Captain Chen said he did not. He had been monitoring the instruments, as usual. Everything had been stable. The inspector asked about the fuel. Had he noticed the arrival fuel being higher than expected? Captain Chen said he had not looked at it in detail. The first officer had handled the post-flight paperwork. As long as the fuel was above minimums, which it always was, he typically didn't scrutinize the exact figures. The inspector explained the discrepancy. 2,400 pounds more fuel than expected based on flight time. Captain Chen looked genuinely surprised. He asked how that was possible. The inspector said that was what he was trying to determine. The interview with the first officer, whose name was David Kowalski, was more revealing. Kowalski was 38 years old and had been with the airline for 7 years. He was more reserved than Captain Chen, but answered questions directly. He described the flight as normal up until the controller's calls about the altitude. He said he had been surprised by the query because all his instruments showed exactly what they should. He had double-checked the altimeters, the flight management system, and the backup instruments. Everything indicated 37,000 feet. The inspector asked about the pauses before his radio responses. Kowalski hesitated, then acknowledged them. He said he had wanted to be certain of his answer before responding. He had glanced at the instruments, verified the readings, and then keyed the microphone. The inspector asked if there was any other reason for the delay. Kowalski hesitated again. Finally, he said there was something, but he wasn't sure it was relevant. He described a brief sensation during the flight of what he called temporal displacement. He struggled to articulate it. He said it was as if time had stuttered, or as if he had momentarily lost track of where he was in the flow of time. He compared it to the feeling of snapping back to awareness after a brief, unintended microsleep, except that he was certain he had not been asleep. He was alert and monitoring the instruments. It was more like a very brief discontinuity in his perception. He said it lasted perhaps a second, maybe two. He checked the instruments immediately after and found everything normal. He didn't mention it to the captain because he didn't believe it was significant, and he didn't want to sound strange. The inspector asked when this occurred. Kowalski said he couldn't pinpoint it exactly. It was during cruise, somewhere over New Mexico. He thought it might have been around the time the controller had called, but he couldn't be certain. The inspector asked if he had felt disoriented or impaired afterward. Kowalski said no. He had felt completely normal. It was just a momentary oddness that had passed. The inspector made detailed notes. He asked if anything else unusual had happened. Kowalski mentioned the fuel paperwork. He said that when he had reviewed the arrival fuel, he had noticed it seemed high, but he had assumed the fuelers at Phoenix had loaded more than the slip indicated, or that the winds had been more favorable than forecast. He hadn't thought much of it. The inspector asked if Kowalski had noticed any other sensory changes during the flight, any changes in sound, pressure, temperature, light, anything at all. Kowalski said he had not. The inspector thanked both pilots and concluded the interviews. He returned to his office and began compiling his findings. The picture was becoming clearer, but also more troubling. The radar data suggested the aircraft had changed altitude. The cockpit data suggested it had not. The fuel data suggested the flight had been shorter than recorded. The time data suggested it had been the duration recorded. And the first officer had experienced a brief perceptual anomaly during the same general time frame. The inspector decided to expand the investigation. He contacted the air traffic control facility at Fort Worth Center and requested an interview with Controller Reeves. The interview was conducted by phone. Reeves described what he had observed in clear, technical terms. He had been controlling traffic for 14 years and had never seen an altitude change manifest that way. Transponder errors were usually obvious, he said. They would show impossible altitudes, like negative numbers or values above the aircraft's ceiling, or they would flicker rapidly between different readings. This had been different. The altitude had changed cleanly, from 37,000 to 41,000 feet, held steady for about 30 seconds, then changed cleanly back to 37,000 feet. If he hadn't known it was impossible, he would have assumed the aircraft had actually climbed and descended. The inspector asked if Reeves had noticed anything else unusual on his scope during that period. Any other aircraft behaving strangely, any radar anomalies, any weather returns. Reeves said no. It had been a quiet morning. Traffic was light, weather was clear. The only anomaly had been Flight 891. The inspector then requested data from the aircraft's satellite communication system. Modern commercial aircraft transmit periodic position, altitude, and speed reports via satellite to airline operations centers. These reports, known as ACARS messages, are transmitted automatically every 10 to 15 minutes, depending on how the airline has configured the system. The inspector obtained Flight 891's ACARS data from the airline. The data showed position reports at 10:45 a.m. and 10:55 a.m. Both reports indicated an altitude of 37,000 feet. There was no intermediate report that captured the 4-minute window in question. The satellite data corroborated the cockpit instruments, not the radar. The inspector contacted the radar system manufacturer, a defense contractor that supplied the FAA's en route radar systems. He explained the anomaly and requested technical support. The company assigned 2 engineers to review the case. They examined the radar installation at Fort Worth Center remotely, accessing diagnostic logs and system performance data. They tested the transponder processing algorithms and the Mode C altitude decoding logic. They found no faults. The system was operating within specifications. The engineers noted that the altitude change observed on Flight 891 was geometrically consistent with the aircraft's position and the radar's line of sight. The radar calculated altitude based on the transponder's Mode C reply, which encoded altitude in 100-foot increments. The encoding was binary and used a specific algorithm called Gilliam code. If the altitude change had been a processing error or a phantom return, it would likely have manifested as an impossible vertical speed or an altitude outside the aircraft's performance envelope. 41,000 feet was within the 737-800 certified ceiling of 41,000 feet. The system had simply reported what the transponder had transmitted. The inspector then focused on the transponder itself. He requested that the airline remove the transponder from November 738 Charlie Tango and send it to an avionics testing facility for evaluation. The airline complied. The transponder, a Honeywell unit manufactured in 2010, was removed and shipped to a facility in Oklahoma that specialized in avionics analysis. The technicians at the facility conducted a comprehensive test of the unit. They powered it up, connected it to a test rig that simulated the aircraft's air data computer, and cycled it through various altitude inputs. The transponder encoded altitude correctly in every test. They introduced electrical noise, voltage fluctuations, and temperature variations. The unit continued to function normally. They examined the internal components for signs of damage, corrosion, or degradation. Everything was in good condition. The transponder was returned with a report stating it was operating within specifications and showed no faults. The inspector considered other possibilities. One was a fault in the aircraft's air data computer, which provides altitude information to the transponder. The air data computer derives altitude from static pressure, measured at the pitot-static ports on the aircraft's fuselage. If the static pressure had momentarily fluctuated due to some aerodynamic effect or a blockage in the static port, the transponder could have transmitted an incorrect altitude. But the pitot-static system feeds multiple instruments, including the primary flight display, the standby altimeter, the flight management system, and the autopilot. All of those instruments had showed 37,000 feet throughout the flight. For the transponder to transmit an incorrect altitude without any other instrument reflecting the error would require a fault isolated to the transponder's internal encoding logic, or the data link between the air data computer and the transponder. Both had been tested and found operational. Another possibility was a GPS altitude error. Modern transponders can source altitude from GPS as a backup or supplementary data source. GPS altitude is less accurate than barometric altitude for air traffic control purposes, which is why barometric is the primary source, but the transponder can switch between sources under certain conditions. If the aircraft's GPS receiver had momentarily provided incorrect altitude data, and if the transponder had momentarily switched to GPS altitude instead of barometric altitude, it could explain the discrepancy. The inspector requested the GPS data logs from the aircraft. The logs showed no mode switching. The transponder had remained in barometric altitude mode throughout the flight. The GPS altitude data, which was recorded separately by the flight management system, showed the aircraft at 37,000 feet during the entire cruise phase, including the period from 10:47 to 10:51 a.m. By late April, the inspector had exhausted the conventional technical explanations. Every system had been tested. Every data source had been analyzed. The aircraft was mechanically sound. The avionics were functioning correctly. The crew was experienced and competent. Yet the data contradicted itself in ways that should not have been possible. The inspector wrote a draft report summarizing his findings. He detailed the altitude discrepancy observed by radar, the fuel discrepancy observed post-flight, the lack of technical faults, and the first officer's account of a brief perceptual anomaly. He concluded that the cause of the incident was undetermined. He submitted the draft to his supervisor at the Flight Standards District Office. The supervisor read the report and called the inspector into his office. He asked pointed questions about the evidence. He was skeptical. He suggested that the radar discrepancy was most likely a transponder glitch that had simply not been reproducible in testing, and that the fuel discrepancy was most likely an error in the departure fuel measurement. Perhaps the fuel truck's meter had been miscalibrated, and the actual fuel loaded had been less than recorded. The airplane had consumed the correct amount of fuel. The starting quantity had been wrong. The inspector pointed out that two separate fuel trucks had recorded the same departure quantity, and both had calibrated meters that were inspected regularly. The supervisor acknowledged this, but said it was still the most plausible explanation. He instructed the inspector to revise the report to reflect this conclusion. On May 2, 2019, the FAA issued a preliminary finding. The report stated that the altitude discrepancy observed by Fort Worth Center was most likely the result of a transient transponder encoding error, cause undetermined. The fuel discrepancy was attributed to an error in fuel load measurement at departure, compounded by favorable winds aloft that were not fully reflected in the pre-flight fuel planning. The report noted that the actual winds encountered may have been more favorable than forecast, resulting in lower fuel consumption than calculated. The airline accepted the finding. The aircraft, with a new transponder installed as a precautionary measure, was returned to service. No further action was recommended. But not everyone accepted the conclusion. Captain Chen, who had retired from the airline in July 2019, made a statement to a colleague that was later shared with the inspector. Chen stated that he did not believe the FAA's explanation. He noted that the fuel load at departure had been verified by two separate fuel trucks, both of which recorded the same quantity. He also noted that the flight's actual ground speed, as recorded by GPS, was consistent with the forecast winds. There was no wind variance significant enough to account for a 42-minute discrepancy in fuel consumption. He didn't elaborate further and declined requests for follow-up interviews, stating he was retired and preferred to leave the matter behind. First Officer Kowalski continued flying. In June 2019, he submitted a voluntary report to the airline's safety department through the company's confidential reporting system. In the report, he expanded on what he had described to the inspector. He wrote that during the flight, at some point during cruise over New Mexico, he had experienced what he could only describe as a temporal discontinuity. He said it felt as though a few moments of time had been excised from his experience. Not that time had passed without him noticing, but that it had simply been absent. He described checking the clock immediately after the sensation and seeing that no time was missing, which had confused him. He wrote that he had not felt fatigued or impaired, and that his instruments had shown no anomalies. He concluded by stating that he was not sure if the experience was related to the altitude and fuel discrepancies, but he felt it should be documented. The airline's safety department reviewed the report. It was categorized as a non-jeopardy informational submission. The safety manager made a note in the file, but did not forward it to the FAA, as there was no regulatory requirement to do so for a subjective perceptual report without corresponding aircraft anomalies. The report was filed and archived. In the months following the incident, 3 other commercial flights reported brief altitude discrepancies on radar in the same general region of airspace over eastern New Mexico and western Texas. None were as pronounced as Flight 891. The discrepancies range from 500 to 2,000 feet and lasted between 10 and 30 seconds. In each case, the flight crew reported that their instruments showed no altitude deviation. The transponders were recycled and the discrepancies resolved. None of the flights reported fuel anomalies. The FAA investigated each incident. In all cases, the conclusion was that the discrepancies were due to transponder or radar processing errors. No systemic fault was identified in either the aircraft transponders or the ground-based radar systems. The FAA issued a technical notice to air traffic controllers recommending that altitude discrepancies be confirmed with flight crews and resolved through transponder recycling before taking any action, such as issuing traffic alerts or altitude assignments. In November 2019, a researcher at a university in Colorado, specializing in atmospheric physics and electromagnetic propagation, submitted a Freedom of Information Act request for the raw radar data from Flight 891 and the three subsequent incidents. The researcher, Dr. Elena Vasquez, was investigating the possibility that localized atmospheric conditions, specifically sudden changes in pressure or temperature gradients, could affect radar signal propagation or transponder performance in ways not currently understood. The FAA released the data after a review process. Dr. Vasquez analyzed the radar returns using signal processing software. She identified a pattern of brief signal delay inconsistencies in the radar returns from all four flights during the periods when the altitude discrepancies were observed. The delay variance was measured in microseconds, far below the threshold that would normally affect altitude calculations, but it was present and measurable. The delays were not consistent with atmospheric refraction or multipath propagation, the two most common causes of radar signal distortion. Dr. Vasquez published her findings in the Journal of Atmospheric and Electromagnetic Research in early 2020. The paper was titled Anomalous Radar Signal Propagation During Commercial Flight Altitude Discrepancies. In it, she noted that the signal delays suggested a brief, localized perturbation in the propagation medium, the air itself, through which the radar signals traveled. She speculated that this could be caused by transient electromagnetic phenomena, possibly related to upper atmospheric electrical activity, though no such activity had been detected by meteorological sensors during any of the incidents. She concluded that further research was needed. The FAA did not comment on the paper. An independent investigator, a former NTSB analyst named Lawrence Brennan, reviewed the Flight 891 case in 2021 as part of a private research project on unexplained aviation incidents. Brennan had worked on major accident investigations for 15 years before retiring. He obtained copies of the FAA reports, the airline's internal documents, and Dr. Vasquez's research through FOIA requests and industry contacts. Brennan's analysis focused on the 4-minute window from 10:47 to 10:51 a.m. He noted that this period represented a gap in verifiable real-time data from independent sources. The radar showed an altitude change. The cockpit showed no change. The satellite system did not capture the moment, as its reporting interval missed the window. The FADEC and FMS data were generated by onboard systems that, while independent of each other, all ultimately relied on the aircraft's own sensors and clocks. Brennan wrote in his notes, which he later shared with a colleague, that if the aircraft had, for any reason, occupied a different state than what was being recorded by its onboard systems, it would create exactly the kind of data inconsistency observed. He offered no mechanism for how this could occur. He simply noted that the data did not reconcile, and that the conventional explanations did not adequately account for all the anomalies simultaneously. He suggested that the incident warranted further investigation, but acknowledged that without additional evidence, no definitive conclusion could be reached. The flight's passengers were never systematically interviewed. Standard FAA procedure does not require passenger statements for technical anomalies unless there is an in-flight emergency, injury, or clear safety threat. Flight 891 experienced none of those. The flight had been smooth and uneventful from the passenger's perspective. They had boarded in Phoenix, flown to Dallas, and deplaned without incident. However, in 2020, 2 passengers independently posted about the flight in online forums dedicated to aviation. The forums were not widely known, and the posts were made under pseudonyms. One passenger described a moment during the flight when the cabin seemed to become unnaturally silent. They wrote that the usual engine noise, the sound of air circulation, even the murmur of other passengers seemed to stop completely for what felt like several seconds. They described it as profoundly disorienting and said they had looked around to see if anyone else noticed, but no one seemed to react. Then the sounds returned, and everything continued normally. The other passenger described a brief sensation of pressure, as though the cabin had momentarily compressed or the air had become thicker. They said it felt similar to what one might experience during a rapid descent, but without any accompanying change in ear pressure or physical discomfort. They checked the flight status display on the seatback screen and saw that the altitude had not changed. They assumed it was just a subjective sensation and thought nothing more of it, until they later read about altitude anomalies in aviation and wondered if there was a connection. Both posts were made months after the flight. Neither passenger provided identifying information or contact details. The posts received little attention and were eventually buried in the forums. They were never verified, and neither passenger came forward to investigators. The aircraft, November 738 Charlie Tango, remained in service with the airline until 2023. During those 4 years, it flew thousands of additional hours without any reported anomalies. Its maintenance record was clean. No recurring issues were documented. In 2023, as part of fleet modernization, the airline sold the aircraft to a leasing company. It was re-registered in another country and continued to operate commercial flights. The new operators reported no unusual incidents. Prior to the sale, the aircraft's complete maintenance logs were reviewed as part of the transaction. The logs showed that the transponder had been replaced in 2020 as part of a scheduled avionics upgrade mandated by new ADS-B requirements. The replacement was unrelated to the 2019 incident. The aircraft's flight data recorder and cockpit voice recorder, which overwrite themselves every 25 hours of operation, no longer contained any data from March 14, 2019. That data had been overwritten within days of the flight. The FAA's final report on Flight 891, issued in August 2019, reiterated the preliminary findings. The altitude discrepancy was classified as a transponder anomaly, cause undetermined, but likely related to transient electronic interference or encoding error. The fuel discrepancy was classified as a measurement error at departure. The report concluded that no safety risk existed and that no further investigation was warranted. The case was closed. The file was archived in the FAA's database, accessible through FOIA requests, but otherwise unremarked upon. In March 2024, 5 years after the incident, a journalist working on a story about unexplained aviation events contacted the FAA requesting information about Flight 891. The journalist had been researching radar anomalies and had come across Dr. Vasquez's paper and Brennan's notes. The FAA provided copies of the final report and confirmed that the case was closed. When asked if there had been any similar incidents since 2019, the FAA stated that altitude discrepancies due to transponder or radar issues occurred occasionally and were generally resolved through standard procedures. The FAA did not consider them unusual or indicative of a larger pattern. The journalist attempted to contact Captain Chen and First Officer Kowalski. Chen declined to be interviewed, stating through his attorney that he was retired and had no further comment. Kowalski agreed to a brief phone conversation. He confirmed the basics of the flight and the altitude discrepancy, but was hesitant to discuss his subjective experience in detail. He said only that the flight had been unusual in ways he couldn't fully explain, and that he preferred not to speculate about what had happened. He declined to participate further in the story. The journalist also attempted to locate passengers from the flight using public records and social media. They were unsuccessful in confirming the identities of the 2 passengers who had posted in the online forums. The story was eventually published in a small aviation magazine in late 2024. It summarized the known facts and noted the unresolved aspects of the case, but did not draw any definitive conclusions. The story received little attention, but the data remains. At 10:47 and 16 seconds on March 14, 2019, Flight 891 was at 37,000 feet, according to every instrument in the cockpit, every sensor on the aircraft, and every system designed to monitor its position. 4 seconds later, the radar return showed it at 41,000 feet. 27 seconds after that, it was back at 37,000 feet. The cockpit instruments never wavered. The crew perceived no change. The autopilot maintained its commanded altitude without deviation. Yet the radar, a ground-based system independent of the aircraft, designed specifically to accurately determine the position of objects in 3-dimensional space, recorded something different. And the fuel tells a different story still. 16,100 pounds were consumed. The engines confirm it. The FADEC logs confirm it. The fuel quantity sensors confirm it. But 16,100 pounds represents 1 hour and 55 minutes of flight time at normal cruise consumption, not 2 hours and 25 minutes. 30 minutes are missing. Not from the clocks, which recorded every second. Not from the GPS track, which recorded every position, but from the fuel, which is a physical, measurable substance that cannot be created or destroyed, only consumed. There is no evidence of deception. There is no evidence of malfunction in any single system. There is only a convergence of anomalies during a specific window of time, each individually explainable, but collectively forming a pattern that defies the explanations offered. The radar could have malfunctioned, but it showed data consistent with an actual altitude change. The fuel measurement could have been wrong, but two independent systems recorded the same quantity. The first officer could have imagined his perceptual anomaly, but it occurred during the same time window as the other discrepancies. Each piece of evidence taken alone can be dismissed. A transponder glitch, a fuel measurement error, a moment of inattention. But together, they form a picture of an event that multiple independent systems recorded differently, as if the aircraft existed in two states simultaneously, or as if the passage of time itself was not uniform across all frames of reference. The families of the passengers have never been informed of the discrepancies. From their perspective, their loved ones took a routine flight from Phoenix to Dallas and arrived safely. The crew moved on to other flights, other routes, thousands of hours in the air. The aircraft continued flying, eventually sold and sent to another part of the world where it still carries passengers today. The air traffic controller retired in 2022 and has not spoken publicly about the incident. The FAA file sits in a server, a collection of PDFs and data files, accessible but unexamined. The sky over eastern New Mexico looks the same as it always has. On any given morning, dozens of commercial flights pass through that airspace at various altitudes, following their routes, monitored by radar, tracked by GPS, logged by computers. Controllers watch their scopes, transponders transmit, fuel burns, time passes. Everything continues as it always has and as it is supposed to. But on March 14th, 2019, between 10:47 and 10:51 a.m. Central Standard Time, a commercial airliner carrying 169 people flying a routine domestic route occupied a space that cannot be fully accounted for by the systems designed to measure and record its existence. Not by the ground-based radar that tracks thousands of flights every day. Not by the onboard computers that monitor every parameter of the aircraft's performance. Not by the physical laws that govern fuel consumption and the passage of time. And not by the memories of the people who were there. The flight landed. The doors opened. The passengers retrieved their bags and went on with their lives. The crew signed off and went home. And no one knew that for 4 minutes, somewhere over New Mexico, the aircraft and everyone aboard it had been somewhere else. Or someone else. Or had existed in a state where the tools humans use to measure reality disagreed about what was real. If you follow aviation mysteries and unexplained incidents, subscribe for future investigations.